Okay, so Cheryl, sometimes you meet someone who just doesn't explain things, they illuminate them. That's totally how I felt after talking to Dr. Katanya Kuntz. I mean, wow.
Oh, absolutely, Heidi. She's incredible. I was thinking we'd just touch on satellites, right? And encryption. But honestly, it was like she handed me a whole new map of the quantum universe? Just mind blowing.
Right? And the satellites part, I thought I kinda got it, but she just made it click. Like, quantum information is so fragile, isn't it? It can only go like 500 clicks in a fiber optic cable before it just collapses.
Exactly. And that's the thing. Classical networks, they use repeaters to clone signals, right? But quantum, no cloning theorem, boom, you can't clone it. So if you want genuinely secure global quantum communication, you have to go through space. She explained how Canada sends single photons up to a satellite and then back down. It's the very early structure of a quantum internet. It's real.
That's wild to think about. But then she also talked about something else that just really got me thinking. The boundary between classical and quantum, it's not a hard line? Like, what does that even mean?
Oh, that was so fascinating, right? She explained that researchers are actively probing that boundary. They take tiny quantum systems and scale them up, or huge classical light fields and scale them down, just to see when does quantum behavior actually start to appear. Because the universe doesn't just flip a switch. So it's gradual, not just boom, one or the other. Yeah, totally gradual and still really mysterious. And hearing her describe those experiments, it felt like getting, I don't know, a peek behind the curtain of reality? She made it clear that probability distributions, wave functions, collapse of states, those aren't just abstract ideas. They're measurable, testable, and they're still full of surprises, which is just incredible.
Okay, but this next part, Cheryl, this absolutely stunned me. Like, I've heard about quantum biology before, but she made it so immediate that quantum processes might already exist inside the human body? What?
I know, right? It was like, wait, what? Yeah, she talked about how a lot of biological stuff like photosynthesis, even how we smell or how migratory birds sense the Earth's magnetic field, they might actually rely on quantum effects. And electron tunneling, she mentioned, could influence our odor detection. Even enzymes potentially using quantum processes.
Wow. So it's not just speculative, it's active research?
Totally active. And the way she spoke about it with such calm confidence made it feel obvious somehow, rather than some far-fetched theory. It totally shifted how I think about biology. And she even touched on the brain, like the possibility of quantum processes there. Not in a hyped-up way, just acknowledging it's an ongoing area of inquiry, and we still have so much to learn.
That just changes everything, honestly. And then at the end, she brought up something that really resonated with me about the future of this field. The most valuable quantum skill might just be translation?
Yes. Oh, that stuck with me too, Heidi. She made it so clear. The quantum workforce isn't just going to be physicists? It's going to rely heavily on people who can take these super complex quantum concepts and make them usable for industries, for executives, for policymakers, engineers, for all of us, really.
So, like someone who can bridge that gap?
Exactly. Katanya lives in that space. She's connected to the deep research, but she's also helping businesses understand what quantum tools can realistically do today. And she creates training for execs. She told us most people won't need a quantum computer at home, but they will need to understand quantum security and post-quantum cryptography. Her work is absolutely vital, connecting with what we do here at Impact Quantum. The future, it's built by communicators just as much as researchers.